A sector is a region of a circle between two radii. So here's a circle, and we've drawn its radius. If we draw any two radii and shade in the region between them, this shaded region is a sector. Next, take a look at these circles here. Which shaded regions are sectors? Exactly, these shaded regions over here are sectors. In this lesson, we'll come up with a way to find the area of any sector. But first, let's look at a circle with radius r. What's the area of the entire circle in terms of r? Right, the area of a circle with radius r is pi times r squared. Next, let's look at a sector, like this sector over here. One property of any sector is its central angle, like this one here. What would you estimate is the measure of this sector's central angle? Nicely done. So it turns out the precise measure of this central angle is 55 degrees. We'll find the area of this sector in a little bit. First, let's look at a sector that's half of a circle. So this is a straight angle measuring 180 degrees. In terms of the radius r, what's the area of this sector? Nicely done. To find the area of half of a circle, you can take its total area, pi r squared, and multiply it by a half. An equivalent way to write this expression is like this, pi r squared over 2. Now where did this fraction 1/2 come from? Well, this sector represents half of the circle. In other words, this 180-degree angle here is half of the 360 degrees that make up a complete rotation around a circle. So 1/2 is the same thing as 180 degrees divided by 360 degrees. Let's try another example. Take a look at this sector over here, whose central angle measures 90 degrees. What's the area of this sector in terms of r? Right, this sector is 1/4 of the circle, so its area is 1/4 times pi r squared. But again, where did this fraction come from? Well, this sector represents 1/4 of the circle's area, just as this 90-degree angle is 1/4 of the full 360 degrees in a circle. So the area of this sector is 90 over 360 times pi r squared. So do you see a pattern for finding the area of a sector? Let's return to our sector whose central angle measures 55 degrees. What's the area of this sector in terms of r? Nicely done. To find the area of this sector, we can start by dividing 55 by 360. So this fraction is how much of the circle the sector represents. And to find the area of the sector, we can multiply this fraction by the area of the entire circle, pi r squared. So for a circle with radius r, a sector with a central angle of 55 degrees will always have an area of 55 over 360 times pi r squared. Can you come up with a general formula? So suppose you have a sector whose central angle is theta. What's the area of this sector in terms of both the angle theta and the radius r? Precisely. So first you can divide theta by 360 degrees. Whatever theta equals, this fraction tells you how much of the circle's area the sector represents. Then, to find the sector's area, you can multiply this fraction by the area of the entire circle, pi r squared. And this is the general formula for finding the area of a sector. So remember, you want to figure out what fraction of the circle the sector represents and then multiply that by the total area of the circle. Let's try applying this formula to a real-world example. Suppose you have a propeller with 3 blades and you want to calculate its area. You might want to do this when figuring out how much force your propeller can generate. When you measure the blades, you find that they each have an angle of 30 degrees. And the radius of the propeller is 4 meters. So what's the combined area of all 3 blades? Round your answer to at least 1 decimal place. This is a tricky question, so if you get stuck, click down here and we'll figure this out together.